I'm Ryan Jarvinen, Ryan J. Here's my my avatar photo here. I work at Red Hat. Even though my hat is black today, I am a developer advocate at Red Hat. Today we're going to be covering an introduction to Kubernetes, so come on in, grab your laptops. It looks like it's right about 1:30 in Ballroom A, so let's get started. If you would like to follow along on your laptop, I have some slides that you can follow along with. Here's the bit.ly URL right here, bit.ly/ATO-K8S. If you go to that URL, hopefully, Wi-Fi permitting, you'll be able to follow along on your laptop. So the way I've organized this content is really intended to be a hands-on, interactive course where you are learning by doing. And if you don't learn by doing in this particular session, the slides have all the information for you to learn by doing later, after the fact, and hopefully enough information for you to relay this information and train someone else on how to do some basic web development using Kubernetes. So that's one of my top-level goals for everyone in this room. And hopefully, I cover a lot of different Kubernetes material, hopefully something in it for everybody. So again, Ryan J., welcome. I was brought to you by Red Hat today, but otherwise, let's get started. So workshop agenda, I'll cover some notes from the workshop setup. If you didn't complete the workshop setup in advance, I've got it all covered in the slides. Feel free to skip ahead if you haven't completed that section. With this many people in the room, I'm expecting some Wi-Fi issues. So get started quick before your neighbor does. Hopefully we'll all be able to participate in workshop setup notes. Feel free to just click on that or follow the link on the course page on the web. Kubernetes Basics will be the next topic we cover. I'll try to introduce you to 5 Kubernetes primitives. These are kind of building blocks that you'll use to architect container-based solutions. So we'll figure out what Kubernetes provides as far as these primitive objects, or Kubernetes resources, as they're often referred to. After that, we'll take a look at Kubernetes architecture. A little shorter session on that, since we'll be using MiniCoup. And lastly, I'll talk about local development with MiniCoup. So I have an intro survey. This is a lot of people, but I like to try to get a sense of the room and see which sections I should prioritize with my time. So just by a show of hands, how many people are doing something with containers today? That looks like a good number of people. The lights are bright, but I would say that's the majority of the room. So these are meant to be kind of decreasing. I'm expecting to see less hands on this. That was probably 80% or more. How many are using Kubernetes or have experience using Kubernetes? This is much lower. This is less than 50%. I'd say maybe 30, 20%, something like that. So good. This will be a lot of new content for you. And since not very many of you are familiar with Kubernetes, less folks who might be proficient, consider themselves to be proficient with CoopCTL, probably fewer people, but thanks for following along. Cool. And these last two, don't worry, but hopefully by the end of the course, you all feel confident raising your hands on these last 2 questions. Can you name 5 Kubernetes primitives and tell me about 5 pieces of Kubernetes architecture? You may not have it now, but hopefully you'll be able to raise your hand for all of these, plus an additional bonus question of, are you ready to onboard a web dev? That's my ideal. Like, if everyone's hands go up, I'll be very happy at the end. Otherwise, I got more work to do on my slides, which is definitely true as well. Introduction to Kubernetes, workshop prep. This is everything that you will need for your laptop environment in order to follow along. The first item is KubeCTL. I've tried to make it easy for most people. I gave the Windows users a little extra challenge. I only had a bash one-liner for OS X and Linux. So those are the ones you get an easy one-line copy and paste. I could do this to just demonstrate, but this has a cost. This will download a very large binary over the Wi-Fi. So I'm going to skip on this particular one. If you already have it, great. Skip this step as well. If you don't have it, this one-liner should get you the KubeCTL command line tool for Linux, and this one for Apple. And if you are not in either of those two camps, click on the official KubeCTL setup notes, and they've got really solid documentation for Windows. I just didn't have a one-liner for Windows. But let me know if you run into any trouble with that one. Next up is MiniCube. Similar one-line install for Windows and Apple, or sorry, Linux and Apple. Windows folks, click through to the official docs. There's an exe file for you to run, really easy to get started. And if you have a laptop with plenty of extra memory, you can set some extra config variables to take advantage of that. This will set some configs to allow 4 gigs of RAM to be used by the VM, and 2 CPU cores to be available. So depending on your environment, this is all going to be running Kubernetes within a single VM for today's purposes, but you can, of course, deploy a full-scale Kubernetes environment. This is just so you can get your hands dirty, learn something, and have an environment that costs you 0 cents to stand up and one that you can take home with you at the end of the day. MiniCoup Basics. Once you have KubeCTL and MiniCoup available, you should be able to run MiniCoup start in order to boot up a VM. I'll run MiniCoup start. Error, looks like, ooh, some kind of bug. I might already have one running. Let's see if I could do a KubeCTL status. Oh, nice. Well, we'll get back to that. You can always, if you run into problems with your MiniCoup environment, which I may or may not be running into problems right now, you can always MiniCoup stop to halt your VM, MiniCoup delete to delete the VM, and then you can run MiniCoup start to init a new blank, empty MiniCoup environment. Each time you do this, you may be re-downloading new assets over the Wi-Fi. So do this sparingly if you don't need to reset your environment. And let me see, KubeCTL version was the command I wanted to run. And it looks like I do have a MiniCoup up and running. So if you run into trouble while trying to start MiniCoup, there's one common issue that many people run into, and it's usually to do with the virtualization support that MiniCoup tries to use. Here's some great 3 reminders for you to keep in mind. MiniCoup does require some type of virtualization backend. Most OSs already include support for virtualization. If you want to opt into any specific provider, you could use the --VM driver flag. And VirtualBox is a nice, sane default. So here, hopefully, if you already have VirtualBox installed, running this line might fix things if you're running into bugs, because it may be getting confused on which VM provider to use. All right, Docker is one thing that you will need if you plan on following along with the later stages, with the local development stages. If you don't want to follow along with the local development, you can skip this slide. I just used a On Apple, you could do brew install. If you have a package manager like DNF or apt-get or yum, you could use those to install Docker. Or you can always get it from the Docker store, download Docker's binaries directly from them. Any of those should work for today's workshop. Last step you'll need for setting up Docker is this eval statement. And you could paste this into your command line. What this will end up doing, I'll take the eval off here so we could see. This, if you have Docker installed, will set some environment variables that should instruct MiniCoup how to use, or instruct your Docker CLI so that when you do your Docker build, the result of that build goes inside MiniCoup. This will save you from having to Docker push out to the outside internet and then pull back down onto our Wi-Fi network. You could just do a Docker build and it'll end up right inside the Kubernetes environment. So make sure to follow along with this eval MiniCoup Docker env statement if you are going to build your own container later. Last step on installation, and hopefully everyone has had a good chance to catch up by now if you're following along. You want to install Git. This is commonly available through a package manager on your operating system. Consult the official Git docs or your OS docs if you need help installing Git. But I'm assuming with this audience, I probably didn't even need the slide. So that's the last step for setup. How many folks are ready? How many folks plan on following along and are not ready? Okay, all right. Are you, same folks, are you waiting on downloads? Okay, good luck. Hope it works out for you. These slides will be up long term. You can always follow along later. And if your neighbor finishes before you, feel free to introduce yourself, ask if you could peek over their shoulder. I know that's not best practices with laptops, but feel free to share your environment if you have someone who got these requirements done early. I'd like everyone to be able to visually follow along. So definitely reach out to your neighbor and check in with them, see how they're doing in regards to downloads and setup. And I'll try to check back in on this topic later and attempt to stall for the folks that are still waiting on the download. So to validate your environment, when you are ready, this is the command that you would run. And I'll get a clean screen here. I'm going to run CoopCTL version. This, like most things from the Kubernetes API, is going to give me two responses. The Kubernetes API generally, well, we'll get into this next, in the next topic. But I got two responses here. The first response is from the client. This is the CoopCTL client version. And I'm running the latest I'm not sure if it's latest now, but the latest major release, 1.8. And it looks like my Kubernetes server version is 1.7.8. If you are feeling adventurous and want to opt in to the latest Kubernetes 1.8 code, you can always run this right here, this advanced challenge option to boot into Kubernetes 1.8. It's still experimental. MiniCoup doesn't have full support for it, and I've heard there's some bugs with volume access, but for the adventurous folks, there's the 1.8 init line. I'm going to stick with my current environment just to save the Wi-Fi strain. Okay, so hopefully some portion of you are ready. Good luck with the Wi-Fi download for the rest of you, and I'll try to distribute more warnings in advance to try to get you set up beforehand. Kubernetes command line basics with CoopCTL. I'll start this section. Hopefully you get a chance to catch up. This whole section is available as a standalone training module starting right here. So if you want to do just this section later, command line basics I have as a individual workshop for you to recycle and share at meetups. potentially. So why Kubernetes? Here's my broad overview. Now that we have setup out of the way. Kubernetes is an open source platform for running container-based distributed solutions featuring fully modular, high available systems architecture. This is kind of a run-on sentence, but I was trying to do my best to sum up what is Kubernetes in a single quote. I think there's a lot going on in there. There's a lot that's kind of hard to describe, but I think fundamentally you're architecting systems using containers, and you're building with a high availability as a default assumption of what your needs are. The best, Kubernetes is also known to be the best way to manage distributed solutions at scale based on, not my experience. Well, let's see. Well, based on what Google might tell you in their they're not using it internally, but they use a lot of these same concepts in how they manage all of their workloads internally. And they've been using containers for over 10 years to run everything from Google Search to Gmail to Google Docs. And just with the number of browser tabs I have open right now, they're probably running half a dozen containers just for my individual user, I might assume, I don't know, that I'm connecting with currently. So I think Google has a lot of experience using containers at scale, and Kubernetes really tries to distill the best of those learnings and offer it to the open source community. So that's one reason I'm really excited about it. It's an extendable modeling language with a huge community following. That's another plus. One of my favorite attributes of what is Kubernetes, it's a multi-vendor effort with a lot of different companies all collaborating. It's not just Red Hat or just Google or just Microsoft or just any other specific vendor. It's really a best of worlds of a lot of different vendors all pitching in, which is maybe different than what you'll see from other folks in the container space. Kubernetes, what it does fundamentally, how it acts on all these things, is it provides an API. Every time you contact the Kubernetes API, you'll see some familiar things in your response. The response is always going to be, usually it's going to be formatted as a JSON or YAML object, and it's going to have attributes generally that look a lot like this. It'll have a kind of type of attribute or a kind of attribute or data packet. Each data resource is versioned. So if I instantiate a container pod with API v1, I know I'll get a certain action. And if I use the exact same data with API 1.1, I may get a slightly different side effect, but I know I have both of these APIs available concurrently, and I can opt into the behavior of either one and reduce the difficulty around migrating across API versions. So the data itself is versioned. There's always almost always a metadata field, and then a spec and a status. And I have an asterisk here because this is mostly true. Almost every type of data you get in and out of Kubernetes usually has all these attributes, and we'll see a few exceptions to this as we go through the content. So these are my big 5 Kubernetes building blocks that I want you to learn throughout this course. This is my first achievement, the first module that we'll go through. We'll start with what is a node in Kubernetes terms. It's not Node.js. What is a pod? What is a service? What's a deployment? And what's a replica set? These will be our building blocks for today. So a node, in Kubernetes terms, a node is a host machine. This can be a physical machine, a virtual machine, bare metal, VMs. Doesn't really matter as long as it has resources and an IP address and can be contacted over the network, but this is where your processes run. The activity on each node is managed via one or more master instances. So there's two types, machine types in Kubernetes generally. There's people who come up with more classifications, but two main. Usually you have your masters, which run the API services, and then nodes where workloads are executed. This is our first command line example. So if you're following along from the command line, get ready to copy and paste. I'm going to have you run this command, and hopefully you'll learn something about Kubernetes as the result. So I'll run get nodes here. Not sure why my laptop is so painfully slow today, but hopefully it keeps up to speed. All right. So it looks like I have one node in a ready status. That's because I'm running in MiniCube, and so I'm in a single VM. If you had a full Kubernetes environment, you might, depending on your access level, see a lot of nodes that are available. I can request the same information, but ask that the results be structured as YAML. Let's give that a try. Here's the same get nodes command, and I'm going to add a -o YAML. So you could see from the output, we have much more machine-readable output here. It's structured. Let me get to the top. Wow, that's a lot of stuff just for one node. So there's attributes that I mentioned you'll see that'll be familiar. API version was one of them. This is versioned data. This is the type of data, and this one is actually a list type. It's saying we have a list of items. So this is a data type that doesn't have a kind or a metadata or a spec or a status. This is one of the special cases that I mentioned. But you could see inside this list option, there's another embedded object. So this is our embedded node object that came back in the response. You could see there's a API version on this resource. There is a type of resource or a kind of resource. Metadata is definitely in there. And there should be, here's the spec, and then a status, right? Just like I said, all output from the API is going to have those attributes from this slide. API version, metadata, spec, status, should all be there. So let's try the same thing. Since we know the name of our node, we can do kubectl get node with the node name. It looks like, oh, I'm talking to GKE. That's what's going on. Okay, minikube stop. Another nice thing about Kubernetes is you could set the context that your kubectl command line tool is talking to. I was talking to minikube raw disk. Ooh, okay. I'm going to potentially ruin my presentation with this. Maybe I should stay connected to, all right, high risk move. I'm gonna try this. I'm gonna try a minikube delete, and what's that? Say that again? Yeah, I know, that's what I'm worried about. Yeah. 30 minutes? Ugh. Okay, so don't try this is what you're saying. All right, okay. Well, let me see if I can find another, all right. Brief moment while I try to fix my kubectl context. That's why I was getting earlier when I did kubectl version. Sorry, you don't need to hear all of my debugging. When I saw the server version was 178, I was actually contacting Google's cloud here. So I have an extra kubectl. Let me see if I can find it. If you want to figure out where your credentials are, you should be able to look in this folder. And I have a config GKE. I'm going to rm kube config And then MiniCoup start. This probably isn't going to do it. Permission denied. Stop. Stop the machine and start the machine again. Could not open MiniCoup. Yeah, I've got some issue with my VM provider. Well, I'm going to rip the Band-Aid off fast and hope this works. And if not, I'll switch laptops. I brought a backup. OK. It looks like I may have the ISO cached. Fingers crossed. So if you ever need to reset your MiniCoup environment, it's very easy. 2 commands, MiniCoup delete, MiniCoup start. Should get you back running, especially if you have your ISO cached. And we'll see if I do shortly. All right. If I wanted more information, human readable API output, I could do KubeCTL describe with the same resource. Hopefully you're noticing a pattern here. These GET requests are going to an API endpoint / nodes. Here we're doing a GET request on node / node ID. Here we're doing a describe on node / node ID. I can also, instead of a slash, we could do a space. But this is basically the resource type and the resource ID. And this is just a convenience for doing basically a API GET request with either JSON or YAML data. Looks like I am downloading a binary. So we'll have a couple minutes while this downloads. Hopefully we all end up with excellent Wi-Fi participation. OK, yeah. Next one, observations. Oh, so observations from this round. Now hopefully you know what a node is. That was the goal for this vertical deck of slides here. Kubernetes designed to exist on multiple machines. You were building a distributed system. The basic platform itself has high availability of node instances and high availability of master instances for running the API. This allows you to scale out the platform. Since you can scale out the platform, you can also scale out within the platform the number of containers you're running within the bounds of how much resources you have. Also, the API ambidextrously supports both JSON and YAML. So if you have a shop that prefers JSON or prefers YAML, you could really standardize on either one, and Kubernetes doesn't really care, which is really nice. OK, next resource type we'll learn about, a pod. Pod is an official scientific term for a group of, anybody know what a pod? Group of whales. It's a group of whales like the Docker whale, ha ha ha, it's a pod. So anytime in Kubernetes where you have multiple containers and you expect them to run together, this pod analogy is the right abstraction for you to use. One of my coworkers at Red Hat, the Steve-O, he has this quote that I really appreciate. He says, pods scale together and they fail together. And this statement is one metric I use for trying to figure out how to architect my systems on Kubernetes. And so when I think of this statement, I think of if I have something with multiple containers and I want to run it together, usually here's a trick I play on the audience. Can anyone suggest an instance where I would have a web front end and some type of back end that I want to run together? Any volunteers? Now that I said it's a trap? No? No? WordPress is a common example that people throw out. So WordPress, would I want my web front end and my DB back end to co-located in the same pod group? Initially, people might think yes, because that would have them physically located on the same machine. They'd have low latency connections. But the real answer is absolutely not. If you want to be able to scale these things independently, or if you want the web front end to be able to fail and restart without restarting your DB, then you definitely want them as separate abstractions. Where pods really shine is if you want to attach a what's known as a sidecar to a process, something like additional metrics monitoring, or maybe some lightweight build process, or some other thing that can run on the side. One example that I like to use is if I'm doing some ops work and I have some logs that are in the wrong format and I want to do some translation on the logs, I could have a sidecar container that processes all the logs, standardizes it into a different format, and writes it out. I should probably have that code in the web code, but if I needed to always attach a logging agent or a metrics agent and make sure that anytime the web front end dies, I always restart the metrics agent as well, and they're always running as a pair. If I want them to scale together and or get restarted together as a pair, that's when I need to use this pod analogy. So for the purposes of this workshop, we will only have one container per pod. So you could almost think of pods as containers. I just need to point out that there's a difference. You can have multiple containers in a pod. So let's take a look at some examples. And let's see, oh, halfway almost. Encouraging, not where I hope to be, but encouraging, okay. Not a total loss. The rest of you can try something like this. And in fact, I might be able to try this since I'm still connected to GKE. No, it rewrote my config. Well, my config's pointed to the right instance now. At least that's fixed. So I can restore my GKE one. No, I'm not going to mess with it. All right. CoopCTL get pods should allow us to list a different type of resource, the pods resource. We should initially see when we run this that we get an empty response. Hopefully, if you're running that on your laptop and you're getting a response, it's probably an empty response. So if you're not sure if it's working or not, it's working, you just don't have any pods yet. If you would like to launch a pod, I have an example. It'll trigger a small download on your laptop, but that's the scenario we're in. So you can run this curl command, and this should download a pod file. And so here's what this spec would look like. And we'll learn about how to generate this type of spec in the next section. So you can see the type of data is a pod. It's versioned data, like I promised we would have. There's a metadata field, as expected. You could see the name of this particular pod, or the desired name that we would like to give the pod. And you could see containers is a list, like I said. We only have one in here, but it's organized as a list, as per this bracket here. You could see the name of the image that we're deploying, or it's given a short name, and here's the path that we're going to be pulling the image from. So I'll do a CoopCTL create on that after my environment comes up. That should deploy the single pod. So if we wanted to, CoopCTL can create resources based on a specification. So this is the spec, the pod spec that we'll be using to create a pod. And we could do CoopCTL create against that local file, that pod.json or pod.yaml. Or we could also do CoopCTL create. The -f stands for file input. So you could do -f. It could be a remote file. It could be a local file. It could even be a directory name with multiple JSON and or YAML files. So there's a variety of ways to say, create this series of assets. And I'm using an example where we're pulling it over the network. The asset manifest, anyway, spec. once we're done with that, we should be able to list pods. Let's see how my progress is going. Making more progress, but I can't list pods yet. We'll run quickly back through these once my environment comes up. If I wanted to see resource by type, if I wanted to see the same thing, all the details for that pod converted into YAML, I can run this. And if you've run it, you'll notice some major changes. I'll get back to this as soon as my environment boots. So observations from this section, pods are scheduled to be run on nodes. We should see that in the output. I'm going to come back to this one. Yeah, we'll see some of that stuff in the output. The next big abstraction we're going to be building with is a service. So far we have nodes, pods, services is our third abstraction, all right? A service, I think, is a difficult thing for me to describe because in Kubernetes, there's sometimes a name collision, right? We talked about node not being Node.js, right? It's a machine, the concept of node as a machine. Service is really, seems like it was named by a networking engineer, right? Where they're talking about, here's all the endpoints for this whole group of microservices, hundreds of them, right? I think service, the better name for it, in my opinion, would maybe be load balancer, because it's meant to be a unique network URL that points to a scaled set of pods. And it'll spread the traffic across all of these pods. So it really acts software-wise as a load balancer. The interesting thing about services is if you start a service on MiniCube, you'll get one type of software load balancer locally. If you start a service on Google's cloud, on GKE, they'll actually hook up some nice Google load balancers instead of this default service type. Most folks, if they have this running on Kubernetes running on Amazon and you request a service, it'll probably go provision a Amazon ELB. So the implementation of how these load balancers are actually provisioned from an operations standpoint is completely separated from how you would make the request as a user. You just say, I need to model things so that this group of resources can talk to this other large group of resources, and communication can flow both ways, but you don't need to say specifically what hardware is used in order to route that traffic, right? You're just doing distributed systems modeling, and you're using building blocks to convey the right concepts so that this solution will be portable to Google's cloud, to Amazon's cloud, or any other cloud. And that's really one of the real compelling aspects of Kubernetes is the portability. Let me check in status check. Aha! I have got to 100%. If you canceled your download to help me get there, thank you very much. Feel free to resume. and hopefully you all catch up. I'm going to try to skip back really quickly to this last page on pods and quickly provision a pod into my new environment. Let's see how this goes. Pod created. All right, I'm back up to speed. Now I can run get nodes much faster. All right, that's why my command line was so slow to respond. It was fighting with the network traffic. So I could see I have one container. The status is container creating because it's trying to download that container over the network. So now as soon as I got my stuff running, of course I flooded the network with more traffic. Sorry about that, everyone. If I want to see specifics on how much progress it's gotten as part of this container creating progress, I can look at some of the detailed API output. So we could see here I did the get pod -o YAML. So I have YAML formatted output. It's versioned data. The type of data or the kind of data is a pod. There's metadata with a lot more information than what we started with. Remember, I don't know if you remember, but I'll go back and take a look at the original spec. And if we compare these, the original spec is really short. This is it. We said we want a pod. There's no creation timestamp. That's null. And there's a spec with our containers. That's the whole thing that we shipped to the API. But yet, when we retrieved it from the API, we got all kinds of data back, right? That's because the API is giving us two different responses, like I said. We have version data, we have metadata, we have a spec. This is what we initially asked for. Now some additional fields have been filled out in here. Like there was a creation timestamp is gone. I got rid of that. The ports have been filled in. Termination message, all this stuff has been filled in. DNS policy, oh, these are all stuff for and then status. So the spec is what we requested, plus a lot of extra stuff that's been filled in by the server as part of the provisioning process. Like I said, if we were deploying something on a service to Amazon, it might go create an ELB. So the platform is filling in a lot of details for us. So we keep our interface simple as a developer and say, here's the minimum of what I need. Go, please fulfill this request. And then the server fills in the rest of the details on how it's going to get the job done. So the way you interact with the API is very declarative. You state explicitly what you need, and then it goes and tries to follow through on that request. So hopefully that's clear based on this file, that a lot more information has been filled in, and this status field has now been added with a lot of output there on how much progress has been made. So big difference from our before and after. That's supposed to be the changes that you notice. And so based on those changes, you should have learned a couple observations. One, pods are scheduled to be run on nodes. You can actually see there's a specific field in the spec called node name, and you could see this was scheduled to be run on a node called MiniCoup, which was my only node, so glad it landed there. Asynchronous fulfillment of requests. So I made a request for the pod to be scheduled, and it happened later, whenever, I'm not sure when, but it happened at some point given network conditions. We have declarative specifications. We say what we need, and hopefully the platform goes and gets the job done. Automatic health checks and lifecycle management for containers are another thing that are added into this pod spec. I don't have any health checks listed, but you can definitely add checks and things like volumes into your specification. Okay? That should be your observations for pods. Services are up next. So services, we would, these are our load balancers, basically. If you wanted to contact the pod that we just started, you can run this command here. CoopCTL expose will generate a service. After that, you can run CoopCTL service and the name of the service that you've created. That should open up a new browser tab. Let's see, I probably have full screen on. Let's see. That should open up a new browser tab. And if you want to see the specific URL, oh, no URL. That's because I left off node port. If you copy the whole example that I have in the slides, it'll cooperate. You need this type node port added. When you're done, go ahead and clean that up, delete that example, and we will garbage collect that particular pod. And you'll learn how to do the delete operation. The API has standard kind of get, set, delete, list operations. So here, now that you've created a resource, exposed it, you should be able to check, again, MiniCoup service metrics K8s and try to reload that pod, and it'll give you an error. That's because the load balancer doesn't have a pod to pass the traffic through to, right? So I'm trying to force you to hit an error with this MiniCoup service metrics K8s. It should not route through. And when you're done, you can clean up the service as well. So that should be basics of just creating a single container and routing traffic into that container. I'm going to try, yeah. We'll see more examples of how to do this, much more sophisticated examples. I would actually never recommend creating pods against the API directly. This is just so you understand the fundamentals, and so the next section makes more sense. Observations from this section. Service basically means load balancer. Pods and services exist independently and have disjoint life cycles. So I can delete a service, which is just the network routing information, or I can delete the pods, which are where the actual workloads are running, and or create multiple services, and they don't need to exist at the same time. You may have errors, but deleting one doesn't automatically delete the other. Deployments are the next topic. So this is the better way to schedule pods. To actual schedule containers on your system, you want to use the CoopCTL Run command. I'm going to add a couple extra flags just to make it fancier. We'll do CoopCTL Run. I'll make a deployment called metrics K8s. I'll use this image from Quay, or Key, depending on how you pronounce it. I'm going to add this expose flag because this will automatically create a service as well. We'll use the node port type service, which works well on MiniCoup. And I'm also going to add a couple extra flags just to complicate it even more. --dry run says, don't actually pass this to the API at all. Just generate the specification and then output it as YAML. So we're basically going to generate a spec that would be shipped to the API, and then instead we're just going to save it to disk, and we're not going to touch the API at all. This is how you would generate new specifications to onboard a new web developer, perhaps, right? Which is something all of you will need to convey if you want to adopt Kubernetes at your shop. So I'm going to copy and paste this whole big, long string. Oops. That's not pasting. Copy this guy. Okay. I paste this string in and save this as a file called deployment.yaml. We could take a look at that, see what we've generated. There is a service with a API version, type, metadata, spec, and status. And then we also see, this is new, if you have an old version of CoopCTL, there was a bug that this separator was not added. This triple dash is a separator between resource 1 and resource 2. So here's our second resource. We've generated a service and a deployment. And if you have the latest command line tools, they've added in the separator so you can output both. But there used to be a bug, and my slides might hint that depending on which version of kubectl you're using, you may have to manually add in that triple dash in between the deployment and the spec and the service. Question for the audience: can anyone think of any other way using maybe perhaps a non-standard resource type, maybe a resource type that doesn't have a kind or a status, or there was one I mentioned earlier. There's a list operator in the API, so that's another way to fix this. Instead of adding the triple dash between the two resources in a YAML file, you can use the brackets in JavaScript and make it a list of resources. But I'm glad the API client's fixed. So let's launch a copy of this. We have our local resource file. I'm going to get one last look at it. This is going to be deploying this container on that port. Let's go ahead and initialize that deployment. That should have created two resource types. And we could see if we do kubectl get resource type 1, comma, resource type 2. This is a trick. You could actually say, give me both resource types, and I've got two API responses. This is how many pods I'm running, and this is how many services I'm running. And then to actually give this a test, let's view it in our web browser. Here we go. To delete the service? Yeah, the command to delete a service, you can run CoopCTL delete service, and then the name of the service, /service name. And if you're unsure what the name of your service is, you can do CoopCTL get service. Or if you're a lazy typer, SVC. That's shorthand for service. So here's my, this is some contributor metrics from Kubernetes that we're displaying here. Any questions about that section? No? All right. Replication. Scaling up the metrics deployment to 3 replicas. Now that we have an easy way to initialize new container-based environments, let's try scaling them. I'm going to do CoopCTL scale. We're going to use the scale command on this type of resource on a deployment. This deploy is shorthand for deployment. And the actual resource ID or resource name is metrics Kates. And I'm going to set the replicas, -- replicas equal 3. Need to make this. Okay. Can everyone read? I'll bump it up one more. That's probably readable. Yeah? Anyone have problems reading that? No? Okay. So now I should be able to check how many pods I have. Get PO is short for pods. Same output, whether I do that or PODS. But you can see I've scaled to 3. If I want to, here's another nice CoopCTL command line trick. Not recommended, but if you're hacking around, you can run. We learned about the get operation. We learned about how to do a list operation by just leaving off the resource name, or we just say the resource type and no name, and that's basically a list. Yeah, get with no resource name is list. Get with a specific resource name is an actual API get. This edit is a lot like a API put, almost. So let's try this. This should open up the resource, the remote resource, in your editor. So for me, this is VI. I can go down here and I could set the number of replicas to 2, and then type in WQ down here, or save and exit, depending on your editor. And look what it did. It actually says that the file was edited. Let me open it again and go ahead and check. Yeah, it looks like now it says replicas are 2 in the spec. And if I try to do the same thing, it says edit canceled, no changes are made. It noticed that I left it at 2, right? If we do get pods, looks like it's shutting 1 down. 1's terminating, we have 2 available. If I do edit again, we could see there's another field, there's our spec, which says we want 2 replicas. There's also, further down, our status, available replicas. This one, I could set this to whatever I want, and it's not going to matter. Yeah, it doesn't increase my number of available replicas, but I can always go in and adjust the spec in a very declarative way, say this is what I need. Don't worry about, I don't need to worry about how it happens, and hopefully I end up getting what I need. I just update the spec, the platform updates the status field, right? I can try to make changes to it, but that's updated by the platform. Does that make sense? Spec field, you set, it's declarative. The status field is the reality of what's actually happening. And so what Kubernetes continually tries to do is compare the spec and the status, look for mismatches, and if you've said my replicas equals 2, and you only have 1 in the status, it's going to continue trying to spin up more containers until your spec is fulfilled, right? This makes it very easy to do a lot of complex stuff. You just say what you need, and hopefully the system goes and tries to achieve that result. Save and quit, we learned what happens there. AutoRecovery, ooh, this is a killer example, and I'm going to speed through it because we're running shorter on time. AutoRecovery, here's one way we can watch this in action. This get pods -- watch or a single -w will do the list operation from the API, but it will leave the API request, the network socket open, and it will continue listening and watching for new pods. So if I do get pods with this watch flag, you could see it didn't return the bash prompt to me. Then I could do in another window, I have a squirrely little bashism here that will do CoopCTL get pods. It will cut out the name of the top 3 of them and then normalize it into a list. I'll do this I'll do this command in 2 sections just so it's super clear what I'm doing. Let me grab another terminal. Okay, so first I'll run the nested command, the nested CoopCTL get command, and you could see what it normalizes everything to is just a list of 3 pod names from CoopCTL get pods. So it's 3 random pods out of that list. So if I run this command, this should delete 3 random pods, okay? So I'm going to move this down here, and we should be able to watch in the upper window how many pods are in action as we're running this command. And you could see some of it gets listed twice, but we could just continually take like shotgun blasts of damage across our dashboard and delete pods groups at a time, and the API will continually look, what's the spec, what's the status, is there a mismatch, and do I need to create more resources, right? So this simulation I'm doing here of deleting pods, this is actually using the API, but if it was a whole node that fell offline with 100 pods running on it, the API would notice this node's unavailable, these pods are unavailable, let's spin up these pods on other available nodes and get us back to where we need to be from a spec perspective. And let's make sure spec and status are in agreement, right? Any questions about that? No? Feel free to follow up later for questions. I know it's hard to do in a big room. Observations from this section. You can use the dry run flag to simulate interactions with the API. A deployment spec contains a pod spec. Hopefully you noticed that in there. This final section on learning API object primitives is about replica sets. Replica sets are kind of hidden from your view, but this is actually doing all the dirty work of a deployment. So here's another, let's do, instead of pods watch, I'm going to do deployments watch. This basically is going to give us a kind of a dashboard for how many containers we have running. You could see it's updating when I did that pod delete statement. Here is our dashboard that's up and running. If I wanted to do a deployment, I could run a command like this. There's a couple ways I could do it, but I'll run a command like this, set image, kubectl set image. I'm going to set the image on the deployment resource. The resource name is metrics Kates, and I'm going to set to this particular, is there an extra? I think this is supposed to be image equals, I think. Let's see if my copy and paste works first. Okay, it's whatever is in my example. Don't follow what I typed. Okay, but we could see here that there's 4 desired. Currently there's 5. 2 of them are up to date. We're doing a rolling deployment across the dashboard that we have. So right here it says contributor metrics at the very top. And if I refresh, still getting the old containers, but at some point I think it switches to Kubernetes metrics or some, I guess it's taken a while to spin up the additional containers, but this should do a rolling update with 0 downtime. So that's a nice feature that usually people have kind of packaged up outside of their platform or maintained on their own or used some off-the-shelf deployment tool. There's a variety of different ways to stitch all that together. But if you really want deployments to be part of and code delivery to be something that's testable, now it is with Kubernetes. You can run your delivery simulation locally on your laptop, and since I'm able to run many containers, I can actually do a full CI pass locally before I promote my changes. And I have some examples on how to do that in our final section. Let me do one more reload. Aha, there, the title changed to Kubernetes contributor metrics because our rolling deployment has finally got us all across to fully healthy 4 requested, 4 desired, 4 up to date, and 4 available. So that was a full rolling update across 4 containers. The way that worked is it used a replica set for deployment number 1 and a replica set for deployment number 2. And we initially had 4 replicas in the initial replica set 1, and we started scaling down replica set 1 at the same rate we start scaling up replica set 2. And so that's one of the ways this rolling deployment is carried out. We can check a history of these rollouts by running kubectl rollout history for that particular deployment. And we can even do a rollback with a command like rollout undo. So here's that going into effect, rolling back all of our changes with the command line kind of acting like a dashboard for how much progress our deployment is getting. Should be all rolled back, so now I should be able to go here, and if I refresh, it says Kubernetes contributor metrics, it should be back to contributor metrics, right? Any questions on that one? Hopefully not, because we don't have time for questions. Sorry, folks. All right. All right, clean up. To clean up all of this that you've done so far, you could run a kubectl delete of both the service and the deployment. List them both together on the command line. Delete service, comma deployment, and then the resource name. And since both resources share the same name, you can use a comma separated resource identifier to delete both. There's our service. That should delete our deployment, and our deleting our deployment will then delete our pods. Right? Here's all of our pods getting shut down and going away, getting cleaned up by the deployment. Observations from this section: the API allows you to watch operations in addition to doing get, set, and list. Replica sets provide lifecycle management for these pod resources, and deployments will then create a replica set to manage replication during that deployment window and switch over from one deployment to another. We're running short on time, so this would normally be where I'd have a pause. The content that I've done so far, we've gone through 2 chapters that I have separated into modules. I have a module on how to set up your laptop with MiniCube, and then a module on learning kubectl tricks. Hopefully at this point, you know some basics of kubectl and can maybe name 5 Kubernetes primitives. The next section I have, I think I might, I'll do a poll of hands, and then we'll see what people want to see more of, because I have 2 more sections and only enough time for one of the 2. So I'll ask you all, how many folks are interested in architecture? Raise your hand for architecture. Oh, whoa, yeah. Well, the other option before, yeah, everyone's like, no, architecture. Who cares what the other option is? All right, the other option is local development tricks with MiniCube. Local development, I show you how to use a volume from your laptop and hook up a local source code folder into the MiniCube VM so you can do live development. I think live development is really what you need in order to make this stuff realistic and to be able to hand off any of this information to your web team. If you can't convey to them how to get quick feedback while developing with containers, then this isn't faster. You know, they're going to have a slower development lifecycle if they're waiting on a Docker build between each change of CSS values or something like, you know, for web developers, they really need to see live development, I think. So this is my latest chapter that I just finished cooking this morning. So hopefully it works. Other than that, we have architecture, and that really goes into how these requests get fulfilled and what happens when you type in kubectl, where the request goes, where the data gets stored, and how the operations behind the scenes actually gets plumbed together. How many people are ops and infrastructure folks versus web dev? Ops and infrastructure, I'm in the ops room, huh? All right, and then how many web dev? I think it's less on web dev, but I have it available as a standalone module, and if I have time, I'll try to speed through that section as well, okay? It should be, they're both easy to follow along on your own, but this one's a little bit nicer to talk over, I think. So for our last, well, we'll see how much time we have. Architecture, let's get at it. Kubernetes, we introduced Kubernetes before. You're managing distributed systems, highly available control plane, uses workloads, run via pod specifications. Yeah, you can actually do a lot of damage to the control plane and have the whole system keep running. And I'll try to show a couple examples of that in this section. To persist all of the platform state in Kubernetes, there's a database that's used called etcd. That's basically where all the statefulness of the whole platform resides. So the first piece of Kubernetes architecture I'd like to introduce is etcd. It's a distributed key value store. It implements the Raft consensus protocol. If you like reading specifications on how things are implemented, you could look up Raft. There's also a theorem about highly available distributed databases called the CAP theorem. And this theory states that you have to pick 2 out of these 3. You can't optimize on all 3, because if you optimize on consistency and availability, you might not have partition tolerance, or if you optimize on availability, you might lose consistency, or this is a kind of a trade-off. You have to pick the right tool for the job, and for this particular job, what we want is a database that can survive failures. We want a control plane that can be shot full of holes and still keep running. And so etcd is one of the tools that helps achieve that. This is a chart, a sizing chart for how many instances you should have in your etcd cluster. And this is based on your tolerance for loss of machines, right? So if you're running in an environment where your machines frequently just go missing for no reason, then you might want to have a larger cluster size with a higher level of fault tolerance. If you have an etcd cluster with 9 nodes, then in order to achieve consensus, you need the majority of these nodes to agree. etcd tries to always have consistent agreement between the master control plane. And so in order for your write to go into the database, it won't acknowledge that the write has succeeded until the write has been replicated to a majority of the nodes in the database cluster. So you're not just writing to the master and then hoping DB replication gets the rest of the job done. You're actually writing to one of many masters that then replicates it and then sends back an acknowledgement that, yes, your data is stored in a way that will, even if we lose nodes, we'll still not lose your data. So that's part of this sizing chart. I think most folks use 3 etcd nodes and often will run etcd on their master instances along with the API. I've seen Red Hat frequently set up 3 for the API server and then 3 separate that they call infrastructure nodes that are just running etcd on their own. So if etcd gets busy or if the API gets busy, they're not competing for the same network connection or the same CPU resources. So cluster size of 3 is pretty common for a full deployment. With MiniCoup, of course, we only have 1. So we are not able to show the high availability aspects quite as well. If you want to play around with etcd, there's a nice simulator at play.etcd.io where you can crash different nodes and watch leader election happen and a lot of other nice things. And it's set up in a way where you can interactively demo with your audience. So if you do talks, it's a nice thing to run through with an audience when you have time for it. The Kubernetes API is another big piece of infrastructure, soft infrastructure that is in Kubernetes. This is the gatekeeper for etcd. So anytime you want to access etcd, etcd is generally unsecured. So if someone had access to etcd, they would probably be able to read all the database secrets or all the passwords or all the configuration for all the nodes and all the, like, way too much information on how to compromise the platform, essentially. So the gatekeeper for etcd is the Kubernetes API, and there's very fine-grained access controls. I think there's role-based access control that was recently upstreamed that a variety of folks collaborated on. This is the Kubernetes API is not required to be up for your pods to be up. It's just for receiving new specs and shuffling information in and out of the DB. But anytime that you send in a request for a pod, if the API is up and your request makes it into the database, a notification then gets sent through. Whoop, I clicked on something accidentally. Architecture, here we go. All right. etcd. We'll see how that information gets routed in a second. There's a nice set of outage simulations that you can run through in this OSCON talk from a year ago. I really like this list because it doesn't work quite as well with MiniCoup, but it shows you how to do things like destroy etcd while the cluster's running and then restore it from backup. Kill the API server entirely and then make sure that you still have uptime on all your pods. And they have like uptime graphs. Simulate a failure of the API scheduler. This one I can actually do from the command line. And we have some slides on how to do it. So we might I'll get back to the slides and we could see how that one would shape up. So if we wanted to simulate a outage of the scheduler, I think that's what this one is. Oh, this is the API server. I could do a kubectl run and launch this deployment, contact it via the web browser. Let's see, it would look kind of like that. Then we can SSH into the cluster. We could look for a process called localkube. Within MiniCoup, there's a binary called localkube that's actually running the API server and the scheduler and I think one other part. And usually I try to like break each of these pieces individually and show how the rest of the system keeps running with any one of them broken. But since they're all tied together in MiniCoup into a single binary called localkube, I can't actually kill these individually. It just kills the whole stack. But I could do a kill all localkube, and then if you quickly log out and list all pods, you should see an error that says connection to the server is refused. You know, it'll definitely error back if you walk through these examples and kill localkube and then get pods right away. If you wait more than a second before running that get pods command, localkube will probably be back up. It automatically bounces back up. And so this is one of those things like you can go through and watch, you could kill the API server, pods will stay up, and API server will come right back up and be available within a second or two. So usually very responsive recovery. And the service will keep running, connection to the pods will keep running. There's another major infrastructure piece called a kubelet. A kubelet is a process that runs on every node and listens to the API server using one of those -- watch flags, essentially. It's going to leave a long-running connection, and it's going to look for any resource that has a spec. And within the spec, we need a very specific thing. We want a spec. It's not in this. Scroll back, it's in my other. We want a spec that says that the node name has been assigned. Spec, where do we got it? Status, here we go, node name. It's going to listen to the API for pods, for services, for deployments, for any object type that has a spec that says node name equals whatever node that kubelet is running on, right? Each kubelet is going to be running on a different node, and so they all listen to the API for any new objects with the label node name equals, hey, it's my name, this is the node I'm running on, right? And then the kubelet will catch that event and provision new containers, right? That's how actual workloads get deployed, is kubelet is listening to the API, watching for things that should land on its node, and then launching them as appropriate. The Kubernetes scheduler will just basically apply that node name. That's all it does. So if you want to simulate an outage of the scheduler, you can look at the difference between these two create statements. And the actual file. One file in here, the only difference between these two, they're two different pod specs. Here's the first one. You could see spec, containers, resources. And the second one is basically the same thing, but it's already been scheduled. And the only difference, is the node name has been added. Here we could see that, node name MiniCoup. So that's all the scheduler is going to do. If you wanted to essentially bypass the scheduler, there's an event in the logs. You could do CoopCTL get events, and you could see when you do a normal deployment, you'll see this, there'll be an event in here from the scheduler where the scheduler basically applies that node name. I've done a whole lot of started container created, killing, created, it should be somewhere in here. Successfully pulled. There's usually, Yeah, here's a bunch of events where the scheduler is jumping in. And if you, from the command line, provision both of these pods, one of them will add an event in the event log that says, hey, scheduler jumped in and took an action. And the other one is just going to skip that step entirely because we've bypassed the scheduler. We've automatically scheduled this to the MiniCoup node by including that in our specification. So that's one way to bypass the scheduler. KubeDNS is basically a way from any individual node or any individual pod. You can do a curl request to the name of the service. So if we name our service metrics K8s, and then we do curl metrics K8s, that curl request will actually go to the load balancer and then back down to our array of pods. So KubeDNS is an internal DNS service that provides discoverability for your containers and your services specifically. KubeProxy is how a lot of, usually traffic gets onto the overlay network. I'm just kind of listing the major architectural components because it's harder to go through and step through each of these. The last major piece that I'd like to point out is Kubernetes controllers. This allows you to run kind of a reconciliation loop. Like the situation I described before, the kubelet is going to use that watch event, listen for the API, and look for things that are named node name with its particular node, and then take an action, right? That type of reconciliation loop where it's constantly listening for actions to take and then taking an action when needed, that's how Kubernetes controllers work. And usually there's a controller for deployment resources. There's a controller for service resources. There's a controller for a lot of different API resources. So as you're going through and requesting, submitting your pod spec or your deployment spec to the API, the controller is noticing that a new spec has arrived, filling in the additional data that's required to actually deploy the asset, and updating the status. Actually, kubelet would update the status as per the results. If all of that sounds like a whole lot of talking and not enough diagrams, here hopefully is the piece that links the picture together. So coming in from the command line over here, CoopCTL, or from any kind of API interaction, we'll be making a call into the API server. So if it was our CoopCTL Run example where we're provisioning a new container, that would come into the API server. The API server would check our credentials, check to see, it basically would store that spec into etcd. The scheduler would then get an alert from the API server that new data has arrived in etcd that is lacking a node name. The scheduler will then apply a node name and save that resource back to the Kubernetes API, which will then put the object back in etcd. Once that happens, the kubelet will get a notification that a resource has been scheduled onto this particular node. It will then basically pull that manifest from the API server and go to provision that resource on the node. Once that resource spins up, it can use things like the service proxy to contact load balancers and the rest of the Kubernetes network. Any questions on this? No? Feel free to hit me up with questions afterwards. One question, yeah. The question was, is etcd the only database that's used with Kubernetes? Today, the answer is yes. There's basically convergence on a single database today. I don't know of any other major players that are really trying to do a Raft-style consensus data store. I think there are other options for certain types of data. You can use things like Vault from HashiCorp for some secrets and other credentials. So I've seen people start to split out some of what's stored from etcd and put more application credentials and application state into a different data store and have etcd be more of the platform state. So it really depends on where you draw the line between what's platform state and what's app state, I think, sometimes, and how secure you need to be on those. But there's a lot of really nice protections around what's visible in etcd. You can restrict a kubelet so that it can only make requests pertinent to things that belong on its node. Or you know, like you could try to scope down the level of access to etcd if that's your angle. Yeah, good question. Last diagram I have is, this is from a Docker blog, so I don't know. They may have been trying to point out the complexity of how complex and hard to understand Kubernetes is versus Docker, and maybe they achieved it via this talk. I don't know, but this is a workflow diagram of how kubectl might step through this interaction, and it's hard to see with this monitor resolution that we have here. But if you have this loaded on your laptop, it's a lot easier to read. Or you could click through to the Docker blog. I'm just having trouble with my screen resolution. But this is tracing the request from the API, the client, to the API server to etcd, and then back to give the client the response that, yes, we've received your request. From there, the API server is going to then make some more requests into etcd and to the controller manager. It's going to go to the scheduler and get its node name. It'll then get passed on to a kubelet, and then talk to Docker to provision the pods. So that's the full kind of workflow diagram according to Docker's blog. That is all I have for the architecture section. So I have about 15 minutes left. Thank you all for sticking around. I'm going to go through, try to speed through, unless there's any more questions about architecture here. No? Okay, I'm going to try to, I know this is a lot of information, and if I was smart, I would just end it right here. Because this is a lot of information to absorb. And I know that a lot of these talks, like one thing I've heard from speakers is like, try to boil it down to 3 takeaways. They're only going to remember 3 things at the end of this talk. So what I have at the end of this talk is links to 3 separate chapters of what I've covered. I don't know if that's helpful, but hopefully it gives you a way to, if you like this content, you can fork any of these slides and recycle them very easily. I have a lightning talk tomorrow on how I do all my slides and my workshop decks. So if that's interesting, stop by the lightning talks. I'll be talking a little bit about how I built these slides today and how I make these workshop modules easy to reuse. You're getting a whole barrage of a whole bunch of workshop modules today, which is maybe more content than I should be dumping on you. But this is an extended session. So I'm going to try to work through one more section really quickly and then get to the wrap up. So what I would cover in this section, I'm just going to summarize, is local development. Here's what Kubernetes provides. We've already said this: standardized packaging, load balancing, scaling automation. How many people need any of this stuff for local development? Nobody. Nobody needs this stuff for local development. So a lot of what Kubernetes, this is why it's hard to sell Kubernetes to web developers. You're trying to sell them on concepts that they don't have any use case for, at least during local development. So hopefully this chapter is what you need if they're far front-end web dev, just doing HTML and CSS and a little bit of JavaScript. This ought to be everything you need. I use a Node.js example in here. So here's some selling points, why you might want to run Kubernetes locally, like we have been in this workshop. One is the ability to offer reproducible development environments. And that's not just MiniCube, but also that deployment manifest that we generated, right? We generated a spec that you could then hand off to a web developer and say, hey, get ready to onboard yourself. It's just kubectl create on this file. That'll get your local dev environment up and running, right? So that's a big win, potentially. Standardizing the onboarding process. Minimizing deltas between dev and production, right? I might not care about load balancers in local development, but if I can model all of those abstractions locally and make sure that what I'm running locally is going to pass the CI test before I do a get push, I can save everyone a lot of time, and I can free up the Jenkins or whatever build pipeline from getting full of a bunch of mess that it's never gonna, like, we ought to be able to figure out these things locally. Now that we can run Kubernetes locally, we could do a full functional evaluation before we promote our code changes. And that's a revolution, I think. Getting that feedback earlier on in the developer lifecycle leads to faster code velocity than we would otherwise have. And this is why I'm interested in using Kubernetes for local development. If I have to stop and do a Docker build to see my results, and it takes 2 minutes, I'm not iterating fast enough. And these tricks is what I use, I guess. Decentralize your release pipeline and allow your CI suite to be run locally, potentially, if you're up for that. That's maybe some extra work, but it'll allow you to have functional systems integration feedback for those devs. And the ultimate is being able to achieve fully offline distributed systems development all on your laptop, all using containers. No one's doing that these days, but with MiniCoup, I think you could basically do it with some of these tips. Not fully offline all the time. You know, you got to download MiniCoup, you got to get your laptop set up. But once you have some Docker binaries, you can really do a lot of work offline on the plane or whatever. So local development checklist. This is what I would expect as a local developer. Someone needs to onboard me. I need to be able to preview my changes, or don't tell me to do Kubernetes. I need to be able to test my changes and promote my changes. Let me speed through these 4 sections. Okay, onboarding. Here's what I would do yesterday. Git clone, change directories into that, and then I'd probably run npm install and npm start for Node.js. This is just if I'm developing, one single microservice. Today, I'd do something like this instead. If I'm onboarding, let's say I'm training someone else, I'm going to do CoopCTL Run, and I'm going to pipe all of this into a metrics review.yaml, and this is how I'm going to do local code reviews. I would then create this and test it out, all right? And in fact, I might just see if I have time. Where am I at? Yeah, I'm gonna copy and paste it and see what happens. Okay. So there goes that step. Let's see if I could just copy and paste and do a speed run through these. Create the resource. Contact the service, preview my changes. Okay, so now I've got a trick, right? Locally, I have a clone, and I think I forgot to include this in the notes. So this is one step that's, oh no, we had it in our last, it was in yesterday's jam. Yesterday's jam, you would need to git clone. Here's a line you might want to copy and paste if you're following along. Git clone this repo, and we'll make some local changes, preview it before we do our Docker build, okay? So I already have a copy of this, and I'm already in the directory. So I'm going to go back to this MiniCoup mount, and I know I'm in the right directory because I just explained that part, right? But I'm going to mount my current working directory inside the MiniCoup VM. And then I'm going to copy my metrics review file, and I'm going to change the name to metrics dev. This is going to give me a, what's going on? Oh, that's that mount process. Okay, I'm going to just leave that running and do some work over here. Okay, so I have a metrics dev file, metrics dev, I'm going to edit this, and I'm going to replace metrics review with metrics dev. I'm going to globally replace that just so I basically can spin up. I could do CoopCTL create on each, and they won't conflict. They'll come up with different resource names, right? So I've got two separate files to work with. I'm going to edit the dev version, and I'm going to add in a volume with this host port type. So sorry, I've got some graphics in the way there, but let's try to paste this in. Oops, vi metrics dev. I'm going to go right down here near the end of the file and do a little bit of cleanup. This is how the file should look. And if you didn't follow along, because I did all of that way too quickly, I have the finished result right here you could download. Click on that link. That'll be the finished result with the host path declaration added in. Once you have those ready to go, you should be able to minikube create-f metrics dev. What happened? CoopCTL create, sorry. CoopCTL create. That should spin up my new local dev environment. I should be able to preview it over here. Let's see, is this it or not? Nope, that's not it. Let me find out where it ended up. Metrics dev URL, please. No URL? CoopCTL get services. MiniCoup X. Well, I could expose. Yeah. Bummer. Well, I did something wrong. But basically the result is what you should have with MiniCoup service, and I'll double check these notes and figure out why it's not showing it. I think I didn't use the node port flag. I think in the service type. I can fix that, but I shouldn't because I'm running out of time. So anyway, what this does is allow you to basically open up your index.html and then go and make as many changes as you want locally. And since your local folder is mounted into the VM, and then from the VM into the pod, then as soon as I make changes locally, I'll be able to make changes and not need to do any type of build. So as long as I'm changing front-end code, I don't need a Node.js web server. I don't need a lot of stuff installed, all my Node.js dependencies. I've abstracted all of that into the Docker image, so I can really distribute all of my onboarding requirements, including the whole build out of the dev environment. I can distribute as containers and then just have them mount their local source repo into the container, make as many HTML client-side changes as they want. This isn't going to work for things like PHP, Ruby, other processes would need a little bit more work, but this is just my, try to get the ball rolling for you folks and show how you would maybe use volumes to mount a local directory into MiniCoup and use that as part of your local development workflow. I will fix the example on the page I had here. I think it just needs the service type equals node port. But I'll definitely troll me online if you have any feedback about that, sorry. And eventually you're going to want to promote your changes. This also has some notes on how you would run Docker build and then apply those changes locally so you can simulate the rollout to your next stage. Your actual code promotion might be a get push, might be a Docker push, might be handled by your CI suite. I really don't know. It's kind of implementation specific, and I'll have to let you fill in some of the details on promoting changes. If you want support for Kubernetes and maybe an upgraded developer workflow, take a look at OpenShift. We do a lot of work around Kubernetes at Red Hat and would be happy to help you get started. If you like these workshops, take a look at bit.ly K8S workshops for a series of each of these sections into kind of bite-sized chunks. So local environments with MiniCube, how to get your environment connected to GKE and gcloud, Kubernetes command line basics, Kubernetes architecture, and then our bonus section on local development. I'll have added to this menu of choices very shortly. Kubernetes documentation's great. You can get free hosting on Kubernetes with OpenShift Starter. And I've got 4 ebooks that you could download for free, 4 free O'Reilly ebooks from Red Hat, courtesy of Red Hat. So feel free to click on any of these links if you'd like an ebook download. And so I know there's very few people left compared to the intro, but so this is a biased. I'm only sampling the folks that stuck around. But out of the folks that are still here, have you ever used containers? Most of you, majority, great, okay. Have you used Kubernetes? Yeah, I'll get to the important ones. How many people feel like they have a minimal basic proficiency with the CoopCTL command line tool? Good, good, all right, good, I did. The people who stayed got some info, all right, okay. How many people feel like they can name 5 basic Kubernetes resources? Pretty good, okay. Pods, services, nodes, deployments, replication controllers. That was the tricky one. Architecture, and hopefully the last one, are you prepared to onboard a new web dev? I may need more work on my last section, but there's more work for the whole Kubernetes community to do around web development. It's a tricky spot. OpenShift adds a lot of nice stuff there. So definitely give that a look. Thank you for sticking around. I'm Ryan J, and this has been Introduction to Kubernetes.